In this video, we are talking about section 11.1, algebra of functions. In this section, we are going to see how do we add two functions together, how do we subtract a function from the other function, how do we multiply two functions together, and how do we divide a function by the other function. So let's see some basics. Let's say we have two functions, f and g. D1 is the domain of f, D2 is the domain of g. We talked about the domain for functions before, right? And we define the addition of f and g as the addition function or sum function of the two functions. The notation for f plus g is f plus g of x. Yeah, seriously, this section is pretty straightforward. If you know the notation, I think you'll be okay. And the domain of the sum function or addition function is the intersection of D1 and D2, or the overlapping part of the domain 1 and the domain 2. It's pretty easy to understand because in order for f plus g of x be well-defined, we require f of x is well-defined, g of x is well-defined. So the domain of the sum function is the intersection or the overlapping part of the two domains. For those x, both of the two functions are well-defined, then that makes the sum function well-defined as well. This is addition. Subtraction. We define f of x minus g of x as the subtraction function of f and g. Notation, f minus g of x. Domain of the new function. This is a one function, okay? This is one function. The function is the subtraction of the two functions. This function has a domain as the intersection of D1 and D2. Same idea. In order for the subtraction function or difference function well-defined, we require both two functions well-defined. So as x is inside the intersection of the two domains, we guarantee the difference function is well-defined. We define f of x times g of x as the product function of f and g. Notation, very important, f times g. Sometimes you don't see the dot. Sometimes you see a dot. They mean the same thing. The product function of f and g. Okay, so f times g. Sometimes you don't even have a dot in between f and g. Sometimes you see a dot. That is the product function of f and g. Same thing with the domain. Domain is the intersection of D1 and D2. Plus minus multiply divide. We define f of x over g of x as the division function, and the notation is f over g of x. Okay, and what about the domain? This one is a little bit different. Variable x cannot assume any value or values which would make the denominator be 0, right? So here the domain, we're going to be very careful. The domain is going to be D1 intersect D2, and then subtract whatever the values would make g of x be 0. Does that make sense? Of course, the value or values make the denominator be 0 would not be in the domain, right? Yeah. So besides D1 intersect D2, the same with earlier, we have to remove all the value or values of x would make the denominator be 0. So that's the domain for the division function or quotient function of f and g. One more thing I want to point out is when we talk about division or subtraction, I mean here and here. Be very careful the order of the two functions. The order does matter. Matters a lot when we talk about subtraction and division. For example, we know 1 times 2 equals 2 times 1, right? 1 plus 2 equals 2 plus 1. So when it comes to addition or multiplication, the order of the two numbers really doesn't matter. 1 plus 2 equals 2 plus 1. 1 times 2 equals 2 times 1. But when it comes to division and subtraction, the order does matter a lot. For example, 1 minus 2 and 2 minus 1, are they the same? Of course not the same, right? They are opposite. And the division, 1 divided by 2 and 2 divided by 1, are they the same? Of course not the same, right? They are reciprocal. Do you see what I'm saying? So you're going to be very careful when you deal with the subtraction and the division. You need to be very careful which function is in front, which function is after, which function is on the top, which function is on the bottom. Okay? And let's see some examples. I said we have 4 examples here. I hope we can finish in the same video. I'll read the requirement for the example 1. Example 1, find the indicated functions and state their domains. Number 1, f is a function. The function is a set of ordered number pairs. -2, 3, -1, 4, 0, 2, and 1, 0. When we talk about the definition for function, we started from relation. Remember that? Relation is a set of ordered pairs. On top of that, if for each domain element there's only one range element, then we call the relation as a function. So this is a function f, another function g, also in the form of a set of ordered pairs, finite set. We have a -2, -1, second element, second ordered pairs, -1, 2, and 0, -3, 1, 1. Very good. So I want you to help me to find the domain of f. Anybody could help me to find the domain of f. Domain is a set as well. It includes all the first components in the ordered number pairs. So that is -2, -1, 0, 1. And what's the domain of G? Same thing. Turns out it's same thing, right? -2, -1, 0, 1. Yeah. 4 components, 4 members. Yeah. So the two functions have the same domain. Then that makes our job a lot easier. We are looking for f plus g. We are looking for f plus g. So I'm gonna go ahead to write f plus g, okay? It's pretty simple. Yeah. How do we find the f plus g? For the first number in the domain, -2, the output for f is 3. Output for g is -1. I leave you to do that part on your own. Look at the notes, the linear function. We need to find f minus g. Let's talk about the domain. Let's talk about the domain of the function f. Do we have any restriction? Yes. This is square root. Remember, the radicand of square root has to be non-negative. So x minus 6 has to be bigger than or equal to 0. We solve this in bigger than or equal to 10. For f, I'm going to use this notation. D of f is this notation, this interval from 6 to pi, left close, right open. And the domain for g is all real, minus x minus 2. Is that understandable? It's pretty simple, straightforward, right? Number 3, f of x x squared minus 4 g of x negative x plus 2. Find f times g of x and its domain. Actually, no, and f times g of 2. Yeah, of course, we need to consider of f times g is all real. Okay, yeah. So that's very straightforward, very clear. The domain of the product function, multiplication of f and g, is all real. It's just plus 2. How do we expect? We have no like terms to combine, so complicated that is, right? This is the function. The product function of f and g is a polynomial function with degree 3. Okay? Yeah. And we have a part in this problem, f times g of 2. Since we have the product function already, we could just plug in 2. Let's see what is f of 2. What is f of 2? I can write it here. Use a different color. F of x is x squared, right? So f of 2 is 0. Right? So f of 2 is 0. And what is g of 2? You don't have to continue, but let me continue here. Because if one factor is 0, then the result, of course, is going to be 0. But let me finish. What is g of 2? Plug in negative 2 plus 2. Happen to be 0 as well. Yeah. So 0 times 0 is 0. Important thing is we understand f times g of 2 is the same with f of 2 times g of 2. So you evaluate function f at 2, you get a value. You evaluate the function g at 2, also another value, and then you multiply. It's a lot easier than you plug in x equals 2 here. If you plug in x equals 2 here, that's a lot of work. Okay? Number 4, the last one. We have function f. It is negative 5x. Function g, x plus 6. Both of them are linear. We need to find f over g of x and its domain. Okay? Yeah. So we can see function f has a domain all real. Function g has a domain all real as well. Then what's function f over g of x? It is f of x over g of x. Is the quotient of the two functions. Numerator negative 5x, denominator x plus 6. And what's the domain? Without thinking about what I talked about earlier in the beginning of this section, just by looking at this function. This function is a rational function, right? It has a denominator. The denominator cannot be 0. We all know that, right? So yeah, what's the denominator? What's the domain? I mean, what's the domain? Domain, of course, is x cannot be negative 6, right? Domain is x cannot be negative 6, because negative 6 would make the denominator be 0. So the domain is domain of f over g here is going to be negative infinity to negative 6 over union negative 6 to positive infinity. The domain is all real except negative 6. So in interval notation, the domain is the union of two intervals, negative infinity to negative 6 open, union negative 6 to positive infinity open. All right? Yeah, so this is section 11.1, pretty straightforward.